In this lecture, we are going to discuss about the Weiss field theory of ferromagnetism. So, in 1907, P. Weiss proposed a molecular field theory to explain qualitatively the nature of ferromagnetism, how the magnetic materials getting this ferromagnetism. Then Weiss postulated that an internal molecular field causes the parallel alignment of the dipole and set up spontaneous magnetization in ferromagnetic materials. This is the overall idea. So, in order to justify that idea, he proposed or hypothesized the concept of domains. What is domain? Domain is a small region. Like what he did is he assumed that solid or maybe any ferromagnetic material consists of a small parts of the region. Each region he treated as a domain, and in the domain the net or all the in the domain the net polarization is in the same direction. So each domain has a different net orientations without field applications. When we apply the field, they will oriented into the same direction. That gives rise to magnetization. So in each domain, spontaneous magnetization is due to parallel alignment of all magnetic dipoles. So in a single domain, all dipoles oriented in same direction. That's the assumption. The direction of spontaneous magnetization varies from domain to domain. So here we can see spontaneous magnetization, this is oriented in different domains in different directions. So that leads to overall net magnetism is almost negligible or equal to 0. So that is the reason. Without field it will be 0, but when we apply the external field, there happens two things. For the alignment of the randomized domains, already randomized, they will align into the same direction. One is by motion of a domain walls, another one rotation of the domain. So what happens is the volume of the domains that are favorably oriented with respect to the magnetized field increases. Then rotation of the domain. When the applied magnetic field is strong, rotation of the direction of magnetization occurs in the direction of the field. Rotation will take place when we apply the strong field. If field is strong, then only rotation will take place. Otherwise, even though with a small field also, the motion of the domains will take place. That thing we can see here. Whenever we initially consider, these domains are randomly oriented. So whenever we apply the field one particular direction, so if we are applying the field in this direction, what happens? Whatever the domains are there in the directions, they start increasing, and other direction domains start decrease. But if we increase the field, once the field is got increased, then we will get rotation of the domains also. This will play key role in the explanation of hysteresis effect. So this is a B versus M curve. Up to some particular point, growth of the favorable domains will take place and unfavorable domains will get shrinkage. Then if we go to higher fields, then automatically rotation of the domains will take place. These are the two factors that will decide, right? Thank you.